yes, this one worked earlier. It's on. Strange. So anyway, so I have to apologize to give you so little warning. What happened was that sometime last year I promised somebody from ACCU out here that I'll tell them next time I was in town. And then I forgot. I'm coming to Alex Fest. Alex did the STL, is the father of the generic programming in C++, had a lot of the influence on concepts that we're getting in GCC next month or the month after. So, very important guy, old friend of mine, so I came to that. And then Friday or thereabouts, I remembered my promise and sent an email that says, well, can you do something? They said, well, we're meeting on Tuesdays. I said, that's not going to help me. Wednesdays. I'm flying home Wednesday. There's only one choice. It's tonight. They said, sure, we'll deal with it. And so we did. And so, anyway, Alex deserves a lot of praise. He is retired as of Friday, and we gave him a good send-up. And then there's a lot of stuff going on in the C++ world these days. I would like to talk about so many things, but you can only talk about one thing, so I'd like to point out that concepts is coming. It's very, very important. If he's going to talk about regular template program, I hope you'll mention concepts. There's both the language features that are done mostly with Andrew Sutton, and Eric Niebler has arranged TS just coming out, so that we can finally say sort of V instead of sort of V.begin, V.end. It's a long way of saying, it's a very, very nice way of saying the same thing. Concurrency, there's some stuff going on. I wrote a paper about it, but everywhere. I mean, we look at ISO CPP. Yesterday morning, there was a new library out. This is great stuff. I have to apologize to Gore and to Sumit Tambe for sort of stepping in just the day before he's going to do it. Look, Gore's coroutines are really cool stuff. You can do really great things with them. Go again tomorrow if you can and listen to it, because it's in some sense more fun than my stuff. And it just goes on and on and on. There's the ISO CPP that you should all be looking at at least once a week, probably more to catch everything. And there's the CPP-Con videos, if you want to know what went on last year. Of course, that's not this year, but you know, most people haven't figured out what happened last year yet. So I recommend that. Okay, so I like pointers. Pointers are really good. I mean, they're the basis of the C memory model, and there's the C, the STL model. And if you look at pointers, they're just machine addresses. But there are very good reasons for liking them. They are the simplest way of addressing something in a machine. As a matter of fact, it's the only way of addressing something in a machine. Everything else indirects eventually through a pointer. That's a machine address. They're general. Obviously, they're general because everything that goes on in a machine uses them, directly or indirectly. They're fast. There's nothing faster. That's the way the machine's addressing mechanism works. And they're compact. Everything that tries to be smarter than a pointer, let's see, will be bigger than a pointer or use a pointer somewhere else. Offsets are just offsets of the pointer. And C's memory model has actually served us very well. I mean, on the bottom of essentially everything we do today is either C or C++, and that is the common thing. It's the basic thing we're working on. However, concepts are not respectable. I mean, if you say pointers are not respectable, if you say you like pointers, people go, ooh, Pointers are dangerous. Pointers are low level. Sure, they're machine addresses. What did I just say? They're not mathematical. No, they're computer stuff. And what are we working on? Computer stuff. And there's a huge ABP crowd, as I call it, anything but pointers. And so I actually like them. If you look at what goes on a machine that's flexible, that's fast, that's elegant, comes very close to a pointer. So I'm going to give this talk about basic pointers and how to use them. And there are some pointer problems. I'll first explain to them in case somebody has forgotten the horrors and never been shown what the horrors are. And then I'll show the pointer. The problem. We'll eliminate dangling pointers, we'll eliminate resource leak, and we'll take care of range errors and null point errors while we are at it. And so in case there's any executives around, I'll give an executive summary. We can do complete type and resource safety. We can guarantee it mechanically. There'll be no litter, no garbage, and no resource will be leaked, whether it be memory or locks or file handles or thread handles and such. We won't leak them. We won't have a garbage collector because we don't generate any garbage. No runtimes overhead except for those range checks which you can't eliminate without crippling a language. And the code will be simpler. And it's part of a larger project to basically decide how to write better C++. So we're saying, what would you like your code to look like in 5 years? Not as you have to write it now with compatibility concerns and a lot of crud. What will it look like in the future? There's a huge set of rules that can be mechanically checked, so you don't have to remember all of them. And this is part of it. It's a key part of it because, well, we would like to get rid of the problems associated with that. And remember, we want C++ on steroids, not some neutered subset. We are not going to solve these problems by running slower on a virtual machine and having to then do the low-level stuff in some other language. Okay, so lifetime can be really messy. We have a bunch of objects, we have pointers to them, we have to figure out when we clean them up. And there can be one reference, two references, circular references, no references, or you can have references that happens to point to nothing. So notice I say pointers, I say references, everything I say work for anything that eventually becomes a pointer in the machine. So smart pointers too. Anything like that. So that's part of the problem. You have to solve that. And then this thing is really hard when you're close to a machine. This is the C and C++ thing that makes it difficult. Look, you can point to a static object, you can point to something on a stack, you can point to something on the heap, or something that's a member of another one. And here I've just made a list right through it. This is really hard to deal with. Remember, this one has to be deleted, otherwise you have a leak. And if you delete that one, you crash. And so you have to tell them apart. Furthermore, resource management can be really messy because a lot of the resources just aren't memory. I mean, a garbage collector sort of cleans up stuff and reclaims memory. But, well, that one contained a lock, that one had a map key, that one had a thread ID. We need to deal with non-memory resources also. So that's the problem. And then finally, once you've got a pointer and you try and use it, you find that it better point to something. So here's a good pointer. It points to a beginning of an object, so you can possibly delete it. This one goes into the middle of it. You better not delete it. And this one went out into beyond the end. You have a range error. Don't use it, or you are in deep trouble with your security guys and with the recovery of the bits when you drop them on the floor. oh, this pointer there went out into outer space. I don't know what it'll do, but it will not do any good, and that's a null pointer. So all of this we have to sort of deal with. And what we need to do, we want no leaks, no littering, no corruption. Every object is constructed before its first use, that was constructors are for, and once only. If you have initialized functions over on the side, you have to remember to call them, you're sort of sunk. Every fully constructed object should be destroyed. You should put it on a stack or in a number of objects or statically. That'll be taken care of by the machine already. But if you put it out in a free store, when you have to remember to delete it. Oh yeah, never, never, never delete the things that are on the stack because they will be destroyed by themselves. And no access through pointers that doesn't point to an object. This is just a summary of the pictures, but we have to do this to get the safety. There are lots of solutions. This is not a new problem, right? I mean, most of us were told when we first started programming, or should have been told, that this problem has to be solved. You can ban or restrict pointers, you can have manual memory management. Just remember to delete all the things that should be deleted. It's easy enough in this much code. It's not easy in a real code base. Garbage collectors, they eat up memory, and they don't actually handle non-memory resources unless you add finalizers, and then you are in real trouble. We can have if anybody think finalizers is a good idea, we can have the discussion offline, because then you have problems. Static analysis, you just analyze the program and see there's no problem. Again, something that works for nice academic paper and a little bit of code. The algorithms tend to be O cubed O to the 4. So don't try it on any real code. Smart pointers, you can do well. You litter your code with smart pointers, especially shared pointers. Then, of course, you have a sort of garbage collected language that works. But those use counts has to be increased and decreased. It becomes an overhead itself. You can have functional programming that just eliminates the whole thing. But then again, I haven't seen very much hardware programming in functional languages because the machines are not built for it. You need something at that level. And so these are partial solutions. They've been around for about 40 years. This was just to remind you that the world was a bit different 40 years ago. That was a popular machine about 40 years ago. And of course the whole machine isn't there because it wouldn't fit in the picture. And it has, no, it's a CDC 6500, 6600. It's a supercomputer, very, very advanced for its time. You need extra floors, you need a room this size to have it in. You need a power plant to match it. And it has, I don't know, hundreds of the power of my laptop. Okay, just think of it as a Raspberry Pi. And the world has changed. And so a lot of this stuff doesn't scale. It doesn't scale anymore. I've said all this before. So basically, we want a solution. And we're going to do this. We're going to be precise about ownership so that we don't litter, and we want to statically guarantee. We want to eliminate the dangling pointers. That takes care that things get created and deleted. That takes care that you don't access something after it's been deleted or before it's been constructed. Make general resource management implicit. As I said, I firmly believe that if we left us to delete things explicitly, we're going to get it wrong. In both of the ways you can get it wrong. One, don't delete it. Two, delete it twice. I don't know which is worse. So we have to hide all of that. And we have to do all of this can be sort of static. We need some checking. You really don't want your arrays to be fixed size and verified at compile time that you don't fall off the edge. People have tried to build languages like that. There are lots of things they can't do. And there are other problems. We'll deal with that separately. This is why this project is part of a bigger problem. This is attacking the specific problem, ownership and access. And now, a lot of people have looked at things like that and says, wow, I need a new language. I mean, people build lots and lots of languages. We get, how many do we get new every year? It used to be about 20 a decade, but it's more like 20 a year now. And I don't want to wait for a new language. It takes many, many years before it is useful, and especially a language that isn't on top of a whole stack of other languages takes even longer to get into place. I don't want to wait for a new standard. The standards committee is getting better, it's getting faster, but there's still a lot of worry and delay and such, so I want it now. And I want it guaranteed. Being careful is not good enough. I want generality, performance, simplicity, portability. This is C++, not something more specialized. So we know how to do low resource leak. Just root everything in an object, every object in a scope, and the constructor destructors will take care of it. We get no naked news, no naked deletes, that's fine. They disappear into the abstractions that takes care of ownership, and basically constructors, destructors takes care of that. If you haven't been doing this for the last 20 years, you should have. This really works, it's good, it's efficient, such. There is one problem left. This is things that are pointed to, and we have to do deletes. Because in that case, we have the remaining case of explicit resource management. These things here, the standard pointers can deal with it, but only with overhead. And you know, one of my rules for C++ is a zero overhead principle. You can't do it better in another language. You can't do it faster in another language except possibly machine code. And when you abstract, you should not be able to write your own version of the abstraction more efficiently. Okay, so we need to do that. I'm not going to talk about that. I'm going to talk about this. That's my nightmare. That's the problems with pointers. That is a real nightmare behind a lot of the C, C++, and just about any other language that has explicit acquisition and release of resources. So here we have a nice little function that looks innocent enough. Takes a pointer, uses it a bit and deletes it. By itself, very innocent. Here we have another piece of code that's quite innocent. I take a pointer, I use it, there. I do a lot more just to confuse the issue, and then I use it again. If you only look here, it's very safe, very simple, very innocent looking, and of course we crash. And this one scrambles your memory or reads garbage, because we just deleted it there. This is sort of the archetype of what mustn't happen. Now, you wouldn't do it in one page, well, there's people that do, but in a million lines of code, you will do it. Okay, so let's see. We must solve this problem, because if you have this problem, you can't guarantee type safety, because another object might be lying at the address of this one, and we may scramble it. You can't get memory safety. Your memory allocator and such can get screwed up. Resource safety in general is totally screwed up, because that depends on both that the memory is uncorrupted and that the types are correct, so that you can call the destructor. And so we're going to eliminate this with a combination of rules. We'll distinguish owners from non-owners. We'll assume all raw pointers to be non-owners. So if we see a pointer like this, we assume it's not an owner. That means that all of your pointers are still going to work as they ever did. We're not going to start writing a whole new language or a totally new style of doing this. and will catch all attempt from an escape, for a pointer to escape into a scope that's enclosing the owner. So you don't want to take a pointer, stick it down here, delete the object, and then use this pointer to get to it. And there's many ways of escaping. Return, throw, out parameters, long-lived containers, lambda, capture, you name it. This is where it becomes engineering rather than science. You need to catch all the cases. And something that holds an owner is an owner. Just that general statement. So the way we do it is very simple. These pointers are all right. They're in the same scope or higher than the owner. There's an owner in there, but that's in an object, so that'll be taken care of by the structure of this one. What we must stop is from it coming down there. That's essentially all we have to do. And if you fire up a bit of static analysis here, it'll say, there is a non-owner. Yeah, I'm deleting it. No, this is bad code. Of course. At compile time, it will never run. Here, I'm getting an owner. Of course, the new delete gives you an owner, because owner is the things that needs to be deleted, right? And the destructor of the fired by the delete takes care of all the rest you want to do. So we will not get past this one. We would not get past that one either if you knew this was an owner, because that's not an owner. So there's endless opportunities for catching it here. And notice those opportunities for catching are strictly local. There's no global analysis here. Okay, let's look at it. Use high-level abstractions. If you think about annotating all of the pointers in a sort of spaghetti-like code, say a large C program, people have tried this. Doesn't scale. After a short while, annotating things becomes a bug in itself, because you write the wrong annotation. So use ownership abstractions, and for the low level, we'll mark the owners. Okay. Representing it with an owner. Here's an example. There's vector. That's my ownership abstraction, my favorite one. It has an owner inside it. This is the thing. This is the pointer that keeps the object alive. And these are two other pointers that relies on this one being alive and pointing into the right thing. So we can now analyze our ownership abstractions and get them right. And this is just an alias. So the other thing we might have to do is, what about code we cannot change? There's a lot of code out there that basically has pointers in the interfaces, and there's an ABI we must obey. And the way we can do that is to annotate it. This owner is just an alias. Did I show you the definition? No, I didn't. I'll do it in the next slide. So here's an owner. I can transfer ownership to that's also an owner. I can call Q, it's not an owner. I can't make it an owner implicitly. That will catch. I delete P2. P2 is an owner? Yep. We can do that, and if we forgot to do it, we'll get caught. Delete this one. It's not an owner, you don't delete non-owners. So we do that with static analysis. Actually, I first tried to do this by thinking about, wait a minute, this is easy. Just add an ownership bit to a pointer, and then let it happen dynamically. Okay, we just lost all the APIs. We also lost all the performance of having simple machine addresses address things. We got yet another smart pointer, because now you want an ownership pointer, an ownership array pointer, and ownership counterpoint. Well, no, you can't do that. That's complicated. Yes?
So a question in this F function here. So P is an owner, and so the intent would be the static analyzer would check the code to see if I did not delete P within F, something is amiss.
Yes.
Because I didn't transfer my ownership. Okay.
That's right.
And the same thing for P2.
Yes.
Okay, so
The fundamental model is very simple. there must always be just one owner. If you forget to delete it because the last owner went away, well, you're in error. If I gave it to you, here it is, then it's your job. And the static analyzer will stop you from deleting it. And after I've given it to you, I can't delete it either. If I take a copy of an owner, I actually get an ordinary pointer. There are 2 papers that explains this in greater detail. There is the sort of ideas paper. I'll show you the reference, but otherwise go into my homepage, find the publication page, take the latest paper there. It's called something like model, C++ model. It gives you the ideas at sort of one level deeper than my hand waving here. And if you want the details, so all of the 50 alternatives for pointers or escaping and such, this kind of analysis is actually done in static analysis using symbolic execution to minimize false positives, etc., etc. There is a, last time I checked, about 50-page document that lists all of that, and it's been currently updated. It's on the GitHub for this kind of stuff. Okay, so I said that. So we're dealing with a cocktail of techniques. There's some rules for using things like an ordinary pointer is an ordinary pointer to a single element, and it what's it called? And it's not an owner. And things like that. And there's a lot of them. Libraries to support it, because we don't want to work straight from the hardware up. We have the STL. STL vector is key. Sometimes we need a smart pointer. There's something called the Guideline Support Library that has a couple of actually, it has about a dozen classes in it. That's all. And they're all simple. I'll show you a couple later. We rely on the type system all the time. That's how we get the RAII, the constructor, destructor things, and static analysis to handle the ownership and the escaping pointers. And each of those techniques have been tried. They're insufficient. They don't scale. Actually, what we are doing here is not restricted to C++. It applies to any language that has manual resource strategies, but it works much better if you can throw in the libraries and the abstraction and the type system. So it has to be a reasonable model language. Okay, how to avoid dangling pointers? Well, here's a function, right? It takes a pointer in, it leaves a pointer out. We all know we shouldn't send out a pointer to a local variable. Even the compilers have known that for the last 30 years. But this is the simplest case, right? Here I am letting a pointer out with that I just made over on the free store. Well, this is an owner, so it'll be okay unless we do ownership analysis. There's also a problem with news assigned to pointers because they're not exception safe. And here I'm returning, that is, this one does not give dangling problems, it gives ownership problems. That's what I mean with this OK sort of. And return P, I got it in, then I can of course send it back where it came from. So that's safe. This is all you sort of roughly need to do local analysis of whether things escapes, because you just have to make sure that nothing escaped into an enclosing scope, directly or indirectly. We can try and do this with owners. Now you will see why it really doesn't work. Here we have P, that came in so it can go out. That's a local, pointer to local, that can't go out. And this is an owner, and I can't specify this type. This type doesn't exist, it cannot exist. Because you actually need to do this, have bits that says which of the elements are owners. There are containers like that in real use. You have to fudge those. They are very, very rare, and usually people have gotten them wrong. But don't mix ownership in an array, and don't let return statements mix ownership. That's not allowed. So basically, here's a summary. Never let a pointer out of scope. It's not just pointers. We have not fleshed out the concurrency things yet, but treat the other thread as another object that might outlive what you do, then this stuff works, but it's overly conservative. So we're still working on that. And you keep the threads alive either by having them scoped or by having the threads known by shared pointers. It's one of the uses of shared pointers. But if you go into the guidelines document, which you can find on GitHub, I'll give you the link later, you can find the rules, and you'll find that these rules for the stack are quite specific. For concurrency, they're a bit weak, and we are asking for help with that. There are other problems, there are other monsters lurking, but they're easier to deal with. They're easier to see. We can see this guy coming, so it's not like my nightmare. He still has bad teeth, you know, but basically there's other ways of making trouble. And there's ways around them that's very well known. Unions, you can use a variant type, cast, just don't use them, they're bad for you. We have a type called span, which is basically a pointer and limit abstraction. A null pointer, we have a null, not null type. And we can try and deal with wasteful ways of addressing pointer problems, especially smart pointers are beginning to be overused to the point that they become a problem in themselves. And just test everything all the time is not a good answer. Not at the level of C++. I can think of languages for which it's very reasonable, but that is not what we're doing. Let's see, this is span. Here's my least favorite interface, key, comma, n. And here I'm doing something. Is this okay? There's no information that will tell me. This looks right? From mine, isn't it? But is it okay? Yeah, it's okay if n really is the number of elements in P, but we don't know that. There's nothing in the type system that helps you. And what we can do is we can have a span abstraction. It used to be called an array view, but the standards guy says that's only for reading. And we want control for read and write. Here, is it okay? You can check it. Span holds both the address and the range. And we can use a range loop because, well, the span knows how many elements there are. So this is the kind of thing that it gives you the safety at a slight cost, and it simplifies the code. Here's another example. We have a function, takes an array, we call it, everything's fine, we call it, it's probably not fine. At least if f takes the, thinks that n there is the size, it's a likely disaster. What we can do instead, give it a span. You can actually deduce what the size is, and here you have to be explicit to give a different size. So if you really want to break this, you can do it if it doesn't check. But everything else, you can just analyze it. If you feed it with an array, it actually knows statically what the size is. So it's simpler, shorter, at least as fast, because there tend to be fewer range checks when you do it systematically. Mixing null pointers and pointers to objects. Confusion. Here's a confusion. There's a function. I call it with a null pointer. Is that all right? Who knows? Try reading the documentation. Do you trust the documentation? I think this stuff here smells. Here is another one. Here's the F, and it tests whether there's a null pointer. Is this necessary? What if the documentation says that you are not supposed to call a null pointer? Should you do it anyway? You may end up testing the same pointer for a null pointer n deep. Not good. And if you get it wrong, you get this. Again, I pointed out this is not just C++. I typed in a null pointer exception, and I'm afraid I didn't find a single C++ code on there. That was a picture. Maybe because we're not as graphical as some of them. Basically, with a null pointer, you can have it. This can be caught by static analysis. If you hide it, say go through 5 functions before you do this, you can have a dynamic check. We are currently having a discussion about whether the constructor for non-null should test, which it is currently doing, or whether we should make not null an alias, just like owner, and then make sure that there's no overhead. But basically, if we take a non-null char, it's not necessary. Notice that again, there's nothing here I'm saying that sort of hasn't been tried before. I think very few of the things I'm saying has not been known for, they've been known for about 40 years at least. But if you try and use it one thing in one way, it doesn't scale, so we're combining it. So there's that one. To summarize, type and resource safety, we use RAII, scope, object, constructors, destructors, eliminate dangling pointers, eliminate leaks, and then we can eliminate range errors and null pointer dereferences. This takes a little bit of dynamic work. This does not. And then we can start attacking other problems that are known, and that's what we're doing in the core guidelines. Here is a summary of some papers. That is the thing that's the next level deep of what I was just doing. What is the model? How do you do resource and dangling? This one here is the currently updated, continuously updated document about the static analysis of how we're doing it. Here's a form, it's a couple paper explaining why this kind of thing is sane. Here are the GitHub for the CPP core guidelines. Here is the GitHub for the guideline support library. Static analysis should have been there a month or 2 ago, but it'll come this month or next. Delays, I'm sorry. But I really wanted to play with it instead of just looking at it and seeing other people's results. But it's not quite there yet, it's coming. Microsoft will be first with it because it's joint work with SOTA and Strays mostly, and a few other people at Microsoft. But some of it is beginning to find its way into Client Tidy and such, and we hope to get GCC on board soon. It is not something that you actually need to build into the compiler. I would think for the debug loops, I'll probably want it as a separate thing that I can turn on and off for the static analysis. But it's not a humongous O to the n cubed algorithm. It's a fairly simple local thing. And you can look at videos about the guideline projects over on the CPP.con sites. It's on YouTube, and I think I don't know if they've gotten them all up on A9 yet. Channel 9. Channel 9 is important because it's not blocked by the Chinese government, for instance. Okay, so some people have asked, what's the boat? Well, it's a very fast ship. It's a surprise for anybody who's into O'Brien. Going through some slightly rough seas faster than anything else. And this is what we're trying to do. It's not going to be smooth. It's not going to be simple. Updating old code bases are never simple. And so I didn't promise that all of your problems will disappear tomorrow. But I genuinely think that the problems related to pointers are going to go away fairly rapidly over the next couple of years. We know how to do it. We've done it for real scale programs. The first implementations will be available, I hope, this month or the next. And so I promised I would talk fast, and that then there will be room for a lot of Q&A. And so we'll have Q&A for as long as it's, you care to, roughly, or they keep us out. And I do suggest that you use a microphone, because this is a very deep room. All come up closer when you want to ask a question.
So before we do that, I'll tell you, we do have, the CPP.con videos are now on Channel 9.
Good.
And that's really nice because you can download them in a variety of formats. You can watch them offline, or even just listen to the audio if you want to do that. Before we get into Q&A, I want to thank Synopsys and Leo for hosting tonight. This is a really great sized group, and so it was good to have a venue that we can do. So thank you guys very much. Thanks, Synopsis, very much. Can I hear, thank you. And I'm gonna have the mic right over here. Anybody who wants to ask a question can come on here.
Yeah, it's really easy as well. Question if you can hear it.
So when we do wrap this up, for those of you who are interested, we're going to go down to Tide House, and we're going to treat our speaker to dinner there. And anybody who wants to join us and ask questions, we'll be there. So.
All right, I guess I'll come up here. So I had a question on the owner stuff, and it was actually specific about the slide, a couple of slides back, when you were introducing the function call with an owner that takes an owner. And I was curious about, there we go, that's good. Sort of in that instance, what if I took and created, say, a P3 object that was actually an auto-ref, P3 equals P2. And at that point, wouldn't it type deduce to say I'm an owner, and so you have an owner reference to an owner?
No, because owner is just an alias that the static analyzer knows.
And so then the static analyzer would see.
Whatever rules you apply, you'll just get the same type again. There's no owners in what the compiler sees. At some point I had it. It's just a type alias, and
so it's ignored by the compiler, but seen by the. It's ignored by the compiler, but seen by the static analyzer. Is what you're saying?
Yeah, the static analyzer knows this, and this is why we work through all the variants of how things escape and how ownerships are transferred. That's a lot of hard work, which is done. Neil McIntosh, who gave at one of the talks at CPPCon, explains this. Where I've got it. That guy. That's the, if you're interested in more details, that's the one you want to read. And that paper there is the one that's being updated each time we find a new way that we can get into trouble. And they thought they would be finished in November, and I haven't seen the final result yet. But we keep finding them. I mean, C++ is a large language. If this had been a toy language, we would have been writing the Pubble paper by now. But I wanted to work on my code. And in particular, I would like to work with the GCC, because I work in a GCC shop, right? It has to be general for all the major compilers, preferably separable from the compiler.
So, come on up if you have questions.
Yeah. If you use the microphone, the guys down there can hear you too.
So, what do you see as the time frame for adoption for each of the major IDEs for compilers, Clang, Visual C++?
I don't know. I mean, it's like asking for a delivery date. I am pretty sure that this is correct.
That's one.
Notice the O. That's the first one. And the spec is public, and I think some of the code is public. Eventually, my condition of working with these guys is that we work under the MIT license. And I know that some people are starting at Clang. I know that we are getting a steady stream of inputs from our friends at Uber and other places for the guidelines. So it's not an isolated small project. I mean, when it started out in the forward, no, when it reached the first explanation in the forward, it was me and friends at Morgan Stanley. It was Herb Sauter, Gavidos Reyes, and friends at Microsoft, and some of our friends at CERN for the numeric parts. But I would be quite disappointed if I didn't have two this year. I'm worrying about GCC. because they're a bit short of manpower. On the other hand, that's the one I really want for real practical reasons, and so I will be trying to push it. The reason I say 1 or 2 years instead of 1 year is exactly that problem. But it's not that complicated once you've got the spec. You need to be able to walk abstract syntax trees with a symbolic execution to avoid too many false positives. But there's a lot of those around.
This is more of a clarification question. So I want to understand, so the static analysis tools that are coming out right now, or that will be coming soon, do they support multi-threading, or is that still an unsolved problem?
They support multi-threading, but they're not very good at it. That's what I said. You have to be too conservative.
So when you say they're not very good at it, do you mean that they might produce false positives?
No, yes, false positives.
False positives, okay.
You treat another thread as another object that might outlive your thread. And that's overly conservative.
Thank you.
So we have questions coming up. So I wanted to ask you about, the core guidelines is on GitHub.
Yeah.
Who is managing the submissions? Is that you personally, or do you have a team? How does that work?
There's a bunch of editors, which there, and then a guy called Andrew Pardo, and we are looking at some of the main contributors to see if we can expand this set of editors.
Okay. But the idea is, there's a lot of guidelines, over 100, right?
Yes.
So you're not expecting every programmer has to memorize these. These are designed for the tools to understand the guidelines, right? And then the tool enforces the guidelines.
My view is that there is a philosophy which is articulated, and the individual guidelines enforce concrete aspects of those sort of more philosophical rules. And if you understand the more philosophical rules, there's about 10 of them called philosophical, but one of the major sections, like interfaces and function calls, have a few semi-philosophical rules. Once you get those, we're talking about a couple of dozen. The rest will sort of, they come up with a rationale, with a reference to, with an example and such, so if you violate them, you're told not just you screwed up again, you're told this is the rule you violated, this is why this rule is there, here's an example of how to get it wrong, probably like what you did, and here is a way of trying to cure it. In some cases we can't be precise totally, but within the overall framework, you're getting a precise message, and you're given some guidance about how to get out of the mess. The thing that's going to create most trouble is that a lot of these rules doesn't actually fit 20-year-old code. And so you can get an awful lot of hits when you start out. And we're still working about ways of gradually introducing this kind of stuff. And this is hard. It's not philosophically hard, it's just complexity is high. And the number of problems are large in those. And we expect people to tell us ideas, this worked, this didn't work, and we can feed that straight in. That's what we hope. Good job.
So this may be asking you to speculate wildly, but speaking of old code, you've got some things here that you can just do static analysis and you know that it may be conservative, but it's definitely correct. And then the stuff that requires sometimes for it, the non-null, and particularly the span thing, that's one that I don't have personal experience with. And I'm thinking about our code base and thinking that, well, we don't really have many places where we do the bad thing already, so maybe it wouldn't be that bad. But to go in and change everything, and there wouldn't be that many places where there could be false negatives. Right? It would be a false negative if you do everything right, but you miss one case and your unit tests don't hit it, then you have a bug, and you did everything right, but you don't know about it yet because your unit test didn't hit it. What are your thoughts on, is there something that might happen in the future to make that easier, or what is the actual extent of the problem? Is it not a problem in practice? I mean, that sort of thing.
There's a lot of problems in practice. And I want the analysis tools to be improved. And the rules are there. Each rule, by the way, has suggested enforcement. Sometimes this is philosophical, you can't enforce it. And sometimes it is, if this precise thing happens, it's an error. And we hope to get more comprehensive there. So, the cleaner your code is, the easier it will be to move ahead. So if you're already writing your code with sort of full RAII, then it should be reasonably easy. If you don't have a lot of really unsafe interfaces, my favorite P, N, which I think is just asking for trouble. If you don't have those, you're doing better. If you're using vector, you're doing better and all of that. And so you go down, and as the programs get more complicated, you have more work to do, but you also have more bugs to find. So we will see what happens there. My dream for a long time actually has been to get not just code analysis, but code transformation. So if you saw the examples, when you saw the examples of P, N and the equivalent span, if you don't have an API problem, you can actually automatically rewrite your code from P, N to span. And then you can sort of crank up and down your testing. And so I think the real answer to a lot of the really old code bases lies in program transformation. There's a fair amount of research in that. It hasn't been done at an industrial scale, especially not for C and C++ where it's most needed. But that's where I would like to see it go. Also, by the way, I promised you could do a Q&A. I didn't say you could only ask questions about the talk. I'm sure some of you had questions about other aspects.
Would it have been possible if the declaration of ownership is actually implicit and only when you're transferring the ownership then you have to write extra code?
That's basically what's happening.
But you have to actually you have to define the alias for owner.
Yes, we have to have somewhere to tell the compiler where ownership is transferred. So, the analysis software knows that what comes out of a new is an owner. Except if you, there's some problems, of course, with placement new, and all of these details that has to be taken care of. But if you have a straight ordinary new, you know you need a straight ordinary delete somewhere. And so you could imagine having no annotations and your code knowing exactly what was right. And maybe it can if your code is not too complicated. And we've been talking about how aggressive should we be in the analysis if you haven't annotated it. But we do know that we need an annotation when things are transferred out of a function scope. Because we cannot take an owner and transfer it to something that hasn't been annotated with an owner. It can't see the new, and therefore it doesn't know that a delete is necessary. If you allow that without annotation, you need a global static analysis, and we're not going there. It's too expensive and too error prone. So it's, the details can get a little bit sticky. It depends on how clever your analysis can be, and we don't want to demand the cleverest analysis on Earth.
So my question is about lifetime management, not necessarily ownership. So let's say we have two objects, A and B, and they're both owned by object O. Sometimes I get tempted to pass, so A and B are brothers, so to speak. Sometimes I get tempted to pass a pointer from A into B. O still owns both of them, but sometimes I want B to be able to observe A. What do you recommend in cases like this where you have two objects that are more like brothers to each other that need to observe each other, but you need to make sure that the one that's being pointed to stays alive still before? So what would you recommend in when I have that temptation?
Yeah, I mean, you have two things here, and they're owners, and you pass an observer over there, just an ordinary pointer. Mm-hmm. And if the one goes out of scope while the pointer is still over there, the ownership takes care of it. I can't, it's too hot, I can't do it in real time. For that, you really have to go to, there's two choices. Go there and see if it's answered.
Okay.
And if you don't find it, send me an email.
Okay.
Yes. But I think it falls out of the rules. That's what I'm getting a bit slow.
That one actually does fall.
What?
It does fall out of the rules pretty easily.
Thanks. He says it works. I say I think it works. And this comes back. Yes.
So obviously, we've seen a lot more happening with machine learning, deep learning, AI, and so forth. There's obviously other languages and platforms that are being used for that, and obviously Google released TensorFlow recently, that is C++, even another language that's the graphs. But anything that you've been doing with machine learning, even Morgan Stanley, any thoughts about this?
No. I have never done anything significant with machine learning. My business is sort of shoving bits around and making sure it's fast and reliable and making sure that the code bases are maintainable. I just don't have the domain knowledge.
How about with Alex Stepanov's new book? Have you heard about From Mathematics to Generic Programmers? Yeah. So would you consider yourself writing a book that's sort of more on the math to the languages that we use day to day?
Look, Alex is a good mathematician. I'm a bad mathematician. It's much better than not being a mathematician. But if I should have it to make a living as a mathematician, I would probably end up teaching high school. And I should stick to what I know. Machine learning is great, it's fun, I wish it's written in C++ to be fast, but I'm not doing it. It's not my expertise.
So in the spirit of the Q&A, I wanted to open up even beyond the talk. So Dr. Tony Hoare, he mentioned that the null pointer was his billion-dollar mistake. Do you feel like you made any mistakes or poor design choices? Is there anything that you might have done differently with the C++ design?
Okay. First of all, I think Tony Hoare's wrong. We just couldn't have built the systems we have without the equivalent of a null pointer or a reference. Clearly he thinks otherwise. But my guess is that it will come naturally anyway. Otherwise you have to have two values, one which is a pointer and the other one that says, well, that's valid or not. And then you get into all this dynamic tracking that I said I've looked at, I've tried, and we'll get there. So I think Tony Hoare's wrong. Secondly, did I make any really big mistakes? Yeah, probably. It's really hard to know what's a mistake and what isn't. Most times when people ask that question, they have in mind one of the major features of C++ that they think shouldn't be there. And I can't think of one of the major things that would improve the language by removing it. I cannot think of any major feature that couldn't be improved, that doesn't have small deficiencies and small improvements that we might have been able to do. On the other hand, some of the improvements that's done to the bigger things turned out to be not improvements. So it's big. And the little things, if I change the little thing, either nobody will notice, and so it's pointless, or it wasn't so little and people will get seriously annoyed and then I've done harm. So I don't have the time machine. I cannot go back in time and say, hey, Bjarne, there, 19 something or other, if you do it this way, things will be right. And I've had this question in various forms. My favorite is actually the time machine question still. If you had a time machine and you could go back and tell sort of an earlier version of Bjarne something, could you have convinced him? And could he have done something about it? Remember, Raspberry Pi is about 1,000 times as fast, has about 1,000 times as much memory as the PDP-1170 I shared with 40 other researchers at Bell Labs when I started this stuff. And that machine was significantly faster than the PDP-1140 that Dennis had in the later stages of building C. And so you can come back with great ideas, but we couldn't have done anything about it. Furthermore, I'm pretty sure I'm not smarter than the sort of the 1990s Bjarne. I may know more, but he knew more about the environment at the time and what could work. So I've been trying to think about what could I have done. And I think if I'd taken the current definition of concepts, as in the concepts TR, and I'd had an hour on a whiteboard with him, I could have showed him how to make templates simpler. And the reason I believe this is possible is that the basics of concepts are simple. It doesn't have some of the known problems. You can look up in D&E, the first 3 pages, and it's apology for not solving the problem. I knew what was my design criteria. I knew I was doing one of these pick 2 out of 3 designs, and good interfaces fell out. Couldn't do them. Nobody knew how to do all 3. But I think if you came back with that one, you could have convinced me.
So when you say
it could have been implemented because it's simpler than what we implemented.
So when you say simpler template programming, do you mean more along the lines of generics, as in Java and C#?
No way. I mean templates, but I mean templates with concepts, which means that you can specify the requirements of the template arguments, both types and numbers. And that's what we're getting. GCC ships it, GCC 6.0. It is a TS now, and I hope to see it in 17. If not, very bad things will happen to libraries over the next few years because they will be hacked as opposed to done properly. So we've got it, and it has no overheads. It has no requirements of introducing base classes or whatever you call it, the equivalent interfaces, protocols, whatever. None of that. It's C++ templates, except that you've got proper type shaping up front, you get good error messages, you can overload onion and things like that.
Thank you.
Okay, now I got 2 things. Okay, so the first one is that me and a colleague who couldn't make it, unfortunately, for this, but we were looking through the classes or support stuff for the GSL, and well, owner is a pretty obvious one, but there's another one that's equally obvious, and I'm not sure if it's just something that was decided wasn't as immediate, or if the idea of I know that you're recommending the use of the range, or not the range, the span.
Span, not span.
For passing pointers or array type memory regions, but for, I guess, annotating pointers that were allocated as an array as opposed to as a single instance, it would be very useful in a lot of places to be able to.
So the idea would be to have an annotation that you put on P and P, N that says this points to an array, and there's an implicit thing that says the next argument is the size. Yeah, you could do that.
Well, no, it's not to say that the next argument is the size. It's to say that if you try to do an increment operation on this address, it's correct if it's invalid. If you try to delete without doing the array delete, so on and so forth. It just seemed to us that was an annotation that covered a lot of other cases where things go wrong.
It's an annotation that's possible.
Is it one that was
People
considered?
have tried it in a variety of languages, and my feeling is that we are now heading onto a slippery slope where we get more and more annotations.
Okay.
And especially my friends at Microsoft throw up their hands in horror because they have annotation systems that has gone truly grotesque.
Familiar with theirs.
There are also other languages that started being simpler and elegant, and C and all kinds of things that just loaded with annotations, and just about every pointer had to be annotated in 2 or 3 ways. And the annotations now become a major source of bugs. And so it's possible, but we're not going there just now. Let's see how we can go with a cleaner solution, which is span type.
Okay.
It's not that we didn't think about it. Currently, there's a lot of discussion about getting a write-only annotation. That is, I can give you a pointer, like a buffer or something, and you can write to it, but you can't read it, probably because I didn't initialize it. The most interesting thing about this is, once upon a time, single classes had two type annotations, read-only and write-only. And to get it into C, the C guys, I had to take away write-only and rename read-only as const. So that would be returned to the very early days. But we are very reluctant to add annotations because some of us have been burned badly.
The other question is, has there been any progress on solving the impact on the standard library of adding concepts or switching over to concepts?
Yes. Look at Eric Niebler's range tiers.
Okay.
It doesn't take everything. I think random numbers have not been conceptualized, or whatever you call it. The rest have.
I was under the impression that with that TS, we're actually looking at basically having to duplicate for backward compatibility pretty much everything.
Yes.
Okay, so
this is STL2.
Okay.
And we knew that, and we were looking at it, and there was general agreement with sort of the people that are interested in the future of libraries. Says no, we need to take minor breakage to move to the concept-related bugs, that is where concept specifies what is right and the library can't do it wrong. There's a few of those. There's actually a few other things, like which return types do you have in certain cases and such. And we should take the opportunity when we get the new standard library to fix those. So the range library does that for the algorithms part that is covering.
Okay. Well, that's good to hear.
There's a lot going on.
Someone asked about something very prosaic that you mentioned very quickly in one of your slides, which is don't use casts. And I've spent hundreds of hours cleaning up large code bases, which had thousands of warnings, just to get rid of and many times my only solution was to cast things. And I'm well aware of the warning, but how can you get around using casts, particularly when you have to call binary interfaces where the types are different?
It is. I mean, if you have to break the type system, you have to use casts. And basically, you shouldn't break the type system. And if you have to interact with badly designed interfaces, usually low-level interfaces and such, you can't get around it. Fundamentally, you need casts only when you are doing things like turning integers into pointers, and when you send a pointer out in a big world, and it comes back from a system interface where you have lost the type. But people write bad code. I mean, there's so much code that they try to be truly object-oriented, and then they cast at every level. So the answer is that for modern C++, you should use more templates, which takes care in a safe way of what people otherwise use cast for. And you should encapsulate some of those ugly interfaces into something that's type safe, so that the casts are in roughly one place for an interface. Now, one of the things that's killed a lot of efforts to improve C++ is backwards compatibility. You can't change the language, so if you break all the code, and people say, my coding standard should give good code, but it mustn't break any of the old code, the stuff that was written back in the early 80s, and C should still work today. Yes, the standard has to obey this. I don't have to when I'm not building the standard. So as I said first, we want to figure out what modern C++ is. What is the code you would like to write 5 years from now, 10 years from now? Set the guidelines from that, and then try and find ways that allows you to approximate that idea. Techniques for updating old code bases. But if you think that the answer, I don't think you do, but if the general you think that the code you're going to write in 5 years should look like the code you write today, then there's something seriously wrong with your ambition level. We really need to improve, and I think we can. And yes, there's code bases that are so messy that it's really hard to deal with, but new code can do it, upgrades can do it, and I really want that code transformation to help me do some of that.
No, I agree with you. It's just somebody gives you
a very real.
It's a very, very real problem. Somebody gives you a couple 100,000 lines of code base, and people are willy-nilly assigning unsigns to signs and shorts to longs, and
and if you compile objects, you just put in a little cast, and boom, everything works. I've seen that too.
Void star this.
Yeah.
No, it's a nightmare.
I've done that, but I've certainly seen it. I try very hard not to do that.
Yes, me too. I don't.
Bad code breeds more bad code. And if you get a bad interface, everything that has to go into the bad interface gets bad. You can't change that easily.
No.
But we have to work away from
it. It would be really nice, but no, you can't.
Here a miracle happens.
I have a question. Can we write some virtual machine like Java and compile C++ into the bytecode so that we can write it and compile one time and run everywhere?
Sure. Of course, you can't do that in Java.
I mean,
you can only run in things that are sort of big enough and regular enough that doesn't have any special things. But yes, you can build a C++ virtual machine. However, that's not what C++ is for. C++ is for using a machine. And there might be places where a virtual machine is useful. People have built such things. They've not been particularly successful because then C++ tend to have the portability restrictions of other languages, of the resource requirements of other languages. So if you want one, get somebody to write it or write it, but I'm not particularly interested.
Maybe you can still do it with LLVM.
You can still do things with LLVM because you can target different machines.
No, I mean, I believe they still have the runtime available.
Yeah, they have. There are dynamic dynamic compilation of C++ in LLVM, but I didn't think that was what you asked.
I'm saying I believe that the code is still. I don't know the last time it was used, but I believe that you can still target the.
I believe it's still possible for Clang to target the intermediate result intermediate stage and run on any machine that the LLVM runtime interpreter runs on.
Okay, I did not know that, so there's an answer for you.
Nobody does it because why would you do that?
Thank you. That was the other part of my answer. What I do find people are using is something like Clang Concern that does runtime compilation.
Yes.
It is you write some new code and you generate it and then you carry on. So,
Thank you.
Okay, about last chance.
So let's take a look at a question. We're going to wrap up by 8:30. So if you have questions and you can wait, you want to have the last one, and that's how you want to time it.
I'll take 8 minutes. So at work we have something that we call or refer to as the string problem, and it's related to us wanting to use code and libraries and, well, yeah, third-party libraries that use string, std string, to pass data back and forth. But we are, in some sense, restricted due to some real-time constraints on dynamic memory. So we can't, or as far as I could figure out, there's no way to use those libraries because you can't use a custom allocator with std strings or somehow allocate a string completely on the stack or anything like that. Is there a vision or anything like that that you can see where, or maybe I'm just misunderstanding how I can go about solving this problem, but is there any way you can see where C++ could go to allow for these kinds of things?
I don't completely understand all the aspects of the string problem because there's many string problems. One of them is that different people have different strings, and you would like to use both that library and they're incompatible. There's also the ones that people want variable length strings, but they want them on the stack, which in general is not possible. In particular, you can do it. So it is. I think the closest you get to a solution is what's coming in this new library, which is the string view, which basically says there's a set of characters, they start there, and this is the last one. And so you separate allocation from use. And that addresses some of the performance problems. There's a thing that I think is very strange, which is string you cannot write. You can only read. You have to take that up in the library group because I never understood it. But that helps in the sense that if I have a string and I want you to do something with it, I don't pass you the string, I pass you the string view. I still control the allocation, deallocation. And since I called you, I'm not going to allocate or deallocate, right? Because you have the thread. So that helps in some cases. Similarly, you can do trickery, allocate an array of characters on the stack, and then you will need a cast, or if they don't have the constructor, I think they have the constructor that says that's the beginning of the string and this is the end of the string. But again, they can't write. I don't understand that one.
You're talking, this is for string view,
String
you're
view.
saying, okay.
So the GSL has one of those, except you can write. It's called string span.
Okay.
And so basically, that's an answer to some of the problems. Similarly, if he has one string and you have another string, and I want to use both of you, don't give me your strings, give me a string span so the characters are able to manipulate.
Well, the other thing is if you design your library using templates, you can say, look, all I need is some idea of a string, and you implement it and pass it into me. As long as I'm just reading from it, it doesn't matter what the actual implementation is.
That does not address the question specifically mentioned, which is on a thread, on a path through the program that mustn't allocate for all kinds of reasons, that doesn't answer it. But then if you only do operations that can't change the size, you're pretty safe.
Right, but my implementation of my string class has the custom allocator built in it, is what I'm saying. So if it's solvable with a custom allocator, which you can't apply to standard string, but if the library is templated on a string idea, then I can give it a string with a custom allocator of whatever sort, and the library is
right. You have to say the concept whether you're willing to have the string grow or not.
Sure.
That is where the
You have to decide what the concept of a string is.
Right, yeah. No, I was more thinking along the lines of a custom allocator. Yeah. Okay, thank you.
All right, this is probably our last one.
Sure.
Come on up.
So,
just in case.
This really is the last one.
Oh, okay. All right.
Okay.
So a slightly big picture question, right? I work on a legacy code base which is finally transitioning to C++ 11, and as I look at C++ 11, 14, and then 17, there are a lot of C++ gotten much bigger now, right? And it's getting even bigger. So for me, like an intermediate programmer, what's your advice on what areas should I spend my energy and time on?
So we had this problem. People want to write modern code. People are adopting C++ 11 faster than they adopted the standard in '98, and they don't know what modern C++ is. So this started out in my answer to what would you like your code to look like in 5 years? And so as you're migrating, look at this to see which areas you should go into and which areas you should stay away from.
Okay, thanks.
Thank you for allowing me to ask the last question. So it looks like those people who think C++ is not the best language, I think it really is. And I think it should not only be the language for you to communicate with the machine. In my opinion, it can be more ambitious. Because there are lots of features that you cannot find in the language that claims to be to provide better productivity than C++. Things like scoped lock or actually lots of things that boost the productivity cannot be found in other programming languages. So the first question, can C++ be a little bit more ambitious to not only be the language you communicate with the machine, but also the language we increase the use in the general application development. And also, I think the idea is something that is not convenient and not really that great with C++. I can only think of two. One is the header file. So it really hurts the productivity because you have to run the same thing twice. That's a declaration under the implementation, and the other is the templates when it is compiled. It creates lots of class that is basically the same thing because, for example, for vector int and vector short, they are two class generator, right? And that makes the object file very big. So is there any way to improve these two?
Yes. We are, yes, that's not the full answer. First of all, I'm trying to get the standards committee to be more ambitious. And we changed the model. Everybody knew it took 10 years to do a standard, and we delivered one in 3 years, and we're going to deliver another one in another 3 years. We're going to get 17. And there's people who are worried about that because you will make mistakes if you move that fast. But you will make mistakes by not going fast too. And my preference is to be more ambitious. I wrote a note about what I thought C++ 17 should be, which you can read. It's somewhere under my name in the WG21 papers, or you can find it by going to my publication page, then the technical report page, and then find it there. Something with C++ 17 in the title. So that's where I think it should be going. That's the full answer. Now, for your specific answer. Bjarne Stroustrup, who was my postdoc and then my colleague for many years, and is now at Microsoft, implemented what was the main designer of something that's called modules. That TS is on its way. There's a reasonable degree of, actually there's a very good degree of agreement about what the core of it should look like. The first experimental version shipped in the most recent Microsoft release. So you can say modules, you can import things and you can export things. It's fairly simple. It's also fairly fast, and it removes the duplication of efforts in the compile phase. So you should get much faster compiles because you're only going to compile what the equivalent of a header once. By the way, I like headers. I like separating interfaces from implementations, and I want to write it twice. Otherwise, you don't actually can't tell a bug from anything else, and you have to look into the implementation, and that becomes the definition. I dislike languages that can't separate interface from implementation. Then you need better interfaces for templates, which is the concept stuff, which is going to be shipped. When is GCC 6.0 coming? They usually come in sort of March, plus minus 1, right? So something like that. That's where you're going to get the concepts. But you can run it, it's on the trunk already. Try it. That takes care of those interfaces. So you get faster compilation, better specification of interfaces. That's coming. What I think we also need to make C++ more popular is simply to simplify some of the clunky syntax in places. There is a phenomenon that I've noticed again and again and again. You have a good idea, and it's fairly simple. And then people go, it's complicated, it's dangerous. We must have a really loud syntax so that you can see if you use it. You mustn't possibly be doing something by mistake or without knowing it. So templates weren't that verbose when I first designed them. But to get them in, you had to add things. And just about any dramatically new feature ended up with a heavy syntax, which people then go and complain about 2 years later. Part of the concept design actually gives you a simpler syntax for writing templates. So if I want to write sort these days, what I'll write is the following: void, sort, open paren, sortable, ref, close paren. That's it. So what you're doing there is you're getting a template that can sort anything that's sortable. That's what you wanted, right? Somewhere else you define what sortable means. Actually, you look it up in the standard. It is a sequence that has a beginning and the end, has random access. I'm fading. And where the element type is, there's a compare operation for the elements.
And it's
that you
rewrite.
get just out of sort or sortable, word sort or sortable. So we're making this is what I work on under the label, making simple things simple. You can still do all the complicated stuff, but it takes more words. So I think you'll find it simpler and faster.
I want to thank everybody for coming out tonight. Great turnout. And our host synopsis. I want to invite you all to come back to the meeting tomorrow night, which is going to be semantic, to talk about code routines, and to join us in San Francisco a week from tonight to talk about template programming, regular template programming. Thanks again. We're now going to go to Tide House, and anybody wants to join us there is welcome to do so. Thank you.